You look at it every day. You have no idea what is actually happening up there. Every second, the sun converts 4 million tons of its own mass into energy, the equivalent of 10 billion nuclear warheads, all at once. It has done this for 4.6 billion years, holding everything within trillions of miles, prisoner to its gravity. That smiley face children draw is a thermonuclear explosion that never stops, the most terrifying object in space. And it is far more dangerous than you have ever been told. Nearly everything you've ever known or touched, oceans, mountains, every city, every living thing, exists because Earth is caught in an invisible crib. The sun holds 99.86% of all the mass in the solar system. Planets, comets, asteroids, all of them are nothing more than debris circling a single, relentless engine. The numbers defy imagination. The sun is so vast that 1.3 million Earths could fit inside its volume. Its mass outweighs Jupiter, Saturn, every planet and moon by more than 200 times. Our world is a speck, locked in a perfect, precarious dance. Earth's entire existence depends on its motion. Right now, the planet hurtles around the sun at nearly 67,000 miles per hour, fast enough to cross the United States in 3 minutes. This furious speed is not a luxury. It is a requirement. If Earth slowed by even a fraction, gravity would win. The planet would spiral inward, falling straight toward the sun's surface. From our current distance, that plunge would last just 65 days. 2 months from blue sky to utter annihilation. Civilization, memory, all of human history, erased in a final, silent arc through space. That is the cost of a single misstep. The sun does not notice or care. Its gravity is absolute, its presence inescapable. The only thing that keeps us alive is momentum, an endless race around a star that could swallow us without a moment's pause. At the heart of the sun, matter is squeezed by a pressure of 250 billion atmospheres. Temperatures reach 27 million degrees Fahrenheit, forcing hydrogen nuclei to fuse and unleashing energy at a rate of 620 million tons per second. Each second, the sun loses 4 million tons of mass, fueling a brilliance that dwarfs any weapon built on Earth. Photons born in this core are trapped, bouncing for 10,000 to 170,000 years before escaping. Meanwhile, 100 billion solar neutrinos pass through every square centimeter of Earth each second, silent witnesses to the fusion within. The photosphere, at 10,000 degrees Fahrenheit, is a turbulent sea of plasma. Granules as wide as Texas boil and vanish in minutes, while sunspots, magnetic scars larger than Earth, dot the surface, waxing and waning in an 11-year rhythm. These features reveal the sun's hidden magnetic machinery storing energy beneath the surface. Above, the corona burns at 2 to 3 million degrees, far hotter than the surface below. The cause remains a puzzle. Some theories point to nanoflares, tiny unseen magnetic explosions, or Alfvén waves, magnetic ripples that carry energy upward. Racing through this furnace at 430,000 miles per hour, NASA's Parker Solar Probe is the only human-made object inside, searching for answers to a mystery that endures. Magnetic fields on the sun twist and not beneath the surface, storing energy like a coiled spring. When these invisible ropes snap, the result is a solar flare, an eruption of X-rays and ultraviolet light that races across space at the speed of light. But the real threat comes with coronal mass ejections. These are not just flashes of radiation, but colossal clouds of magnetized plasma hurled into the solar system, each weighing billions of tons. In September 1859, the Sun launched a coronal mass ejection directly at Earth. Within hours, telegraph systems burned, operators were shocked, and auroras lit the skies as far south as Cuba. The Carrington event, as it became known, remains the most powerful solar storm ever recorded. If such an event struck today, the world would face a blackout of a different order, $1 to $2 trillion in damages, with recovery stretching from 4 to 10 years. Modern life, including satellites, power grids, and internet cables, rests on a razor's edge. The danger is not history. In July 2012, a coronal mass ejection of Carrington scale exploded from the Sun's surface. It missed Earth by less than a week. Had our planet been in the line of fire, the warning would have been measured in minutes, 15 to 45 minutes at best. There is no shield, no negotiation, no mercy. The Sun's violence is not a question of if, but when. The Sun sends a steady wind of charged particles, racing outward at up to 2 million miles per hour, shedding 1 million tons of material every second. This wind carves out the heliosphere, a vast bubble stretching more than 120 times farther from the Sun than Earth's orbit. In 2012, Voyager 1 crossed this boundary, leaving the Sun's influence after 35 years in flight. Mars, once home to rivers and a thick atmosphere, lost its protection and was stripped bare by solar wind over eons. Earth's magnetic field still shields us, though auroras flicker as reminders of what lies beyond. At 4.6 billion years old, the Sun is middle-aged. In 1 billion years, rising heat will boil away Earth's oceans. 5 billion years from now, the Sun will swell into a red giant, then shrink to a white dwarf. Compared to giants like R136A1 or Betelgeuse, our Sun is modest, dangerous, but steady enough for life. Civilization balances on the edge of a boiling, indifferent star. 4 million tons of mass gone to fire each second. The Sun will keep burning long after our species vanishes. Keep looking up. Stay curious.